We all know about AI, and then we are into AI agents. How many of you have started thinking about the internet of AI agents? Okay, a few of them. Or some people call it agentic web. And if you compare with the World Wide Web of Tim Berners-Lee, 1990s, there was a lot of pressure. There were players who were trying to create browsers that are not compatible with the ecosystem. AOL and CompuServe were creating its own walled gardens. Companies were rushing to file IP on all kinds of open technologies. But Tim Berners-Lee and others, let's call them freedom fighters, kept the web open and neutral. And what does it mean to do that today? So we have a fantastic panel today. I'm going to start off with a couple of opening comments, and I'll ask each of my panelists to introduce yourself and give 2-minute opening comments, and we'll have a lively conversation. So if you think about the agentic web, we have billions, maybe trillions of agents that need to talk to each other, find each other, transact, learn from each other, and create societies. And this has been kind of my research at MIT. I'm a professor at MIT on thinking about decentralization of AI and AI agents. And we think we're kind of going through 3 phases. The phase 1 is AI foundations, getting the registry and index and authentication and trust and reputation right. The second phase is agentic commerce. And it's not just about transacting in money and data and services, but we'll be transacting in intelligence. So if I say I want 0.5 kilogram of Sichao's intelligence, what does that mean as an agent? How do I price it? How do I measure it? And do I have unlimited rights to use his intelligence, or I can only use it for myself? Can there be double spend? That's the second phase, kind of agentic commerce. And the third phase is agentic societies, where if you move into a new city, as individuals, we don't just focus on getting our driver's license and finding a job, but we also create societies. We have sports teams, we have stock markets, we have justice systems. So all these new entities emerge from it, and something similar will happen in the agentic world as well. But coming back to the first phase, which is agent foundations, what does it mean to create like a DNS of AI agents? Like we have DNS for websites. And what does it mean to have a new ICANN that can make sure that there is some interoperability and understanding how all these agents will talk to each other? Do we need a new World Wide Web consortium like Tim Berners-Lee did at MIT? Do we need a new Mozilla on the interfaces? Do we need all these new entities to get that going? So one of the projects we're working on at MIT is called Nanda. Nanda stands for Networked AI Agents in Decentralized Architecture, but Nanda is also the name of my sister. And in this network AI agent world, I think we have a lot of work to do. And there's some early good protocols we have seen, like MCP and A2A and so on. But it's not enough to have open source and open protocols, because a lot of other things have to go right to make sure we keep this an open and neutral web. With that, I'll hand it over to Sichao for his opening comments.
All right, I'm Sichao Wan. I'm a product management leader in Cisco Systems. And as everybody knows Cisco, we build, hyperscale infrastructures and supporting networking AI, and also we build collaboration security, secure enterprise between user and applications and internet. Now we have to cover agentic AI, make sure agents are actually comply with the policy, and whatever they do, whatever they access.
Hi, I'm Debo Datta. I run AI at Nutanix. For those who don't know about Nutanix, we are a platform and data management company that allow enterprises to run their traditional workloads and their modern workloads, which brings me to this. The new modern workload for the IT is essentially multi-agents. And so in order to kind of make that happen, we want to be participating in open frameworks, open foundations for this agentic web, so that enterprises, we want to help the enterprise build their new workloads and run these new workloads for their own benefit. And in order to understand, when people ask me, so what is this agentic web? What's this Internet of Agents? actually, my teenage daughter asked me that too. So I told her, you imagine the Despicable movie series, right? Me movie series. So you have these minions talking to each other in Minionese. So the minion could be a single AI agent talking to each other to do a job. And now imagine if you've seen the movie, if you don't put the right guardrails, if you're not a good guru, you can have unintended consequences around you, and especially in the enterprise where data is so critical, and this could be it could play havoc in your enterprise. So how do you build this? How do you have agents talking to each other? Is very, very important for every enterprise. If you're part of an enterprise and you've not started thinking about it, the time was yesterday.
Thank you. Well said. My name is Sam Sharaf. I'm a product leader within Salesforce, Agentforce team, focus on developing next generation of agents. And then very focused on that is how to make these agents talk to each other, how to make these agents interoperate, and then also be able to work in a distributed environment. So like Dr. Ramesh said earlier, we are, I think, in the very, very first phase of AI agents, right? So right now, organizations are determining, hey, what is the ROI of replacing the existing business processes with AI agents? But then as we move to the next phase, as that ROI is proven, the next phase is how to make agents talk to each other, play with each other, right? To solve an end-to-end use case. A particular focus of area of research, and within Salesforce, we have a branch called AI Research, which I was part of earlier. And what we were experimenting there was that smaller fine-tuned models, which are domain-specific, can be actually very performant and fast compared to larger general-purpose models. If you apply that to AI agents which are domain-specific and working with domain-specific models can actually achieve an end-to-end use case in a much better, effective way. For example, think of procurement, right? You have a business process involved, right? There's a fulfillment agent, there's a sales agent, there might be a factory agent. How do these agents proactively can work together to not just solve an end-to-end use case, but also provide some early signals? And then also another area of what you're working on is I've contributed towards the A2A spec, which how many of you have heard of A2A, agent-to-agent interop spec? So it's now part of Linux Foundation, and we are working actively towards improving it. But a key part of that is what Dr. Ramesh and you said earlier is the concept of observability, guardrails, policies, security, and trust. Right? It's one thing to have the minions play together a game of agents, right? But when you are operating in a highly regulated financial services industry or healthcare industry, right, where the chance of error is very minimal, you want to have very effective guardrails, policies, and all that in place, along with full traceability and observability. So those are the key factors which we are working on.
Hi, everyone. My name is Bobak. I'm the CTO for Cognizant, a relatively large services company, where we are actually developing very large-scale multi-agentic systems for our clients and for ourselves. And when I say large-scale, I'm talking about hundreds, hopefully going to thousands, which does require coordination mechanisms to make these agents discoverable, to be able to plug a new agent in and extend an agentic system automatically. And we've open sourced this, it's called NeuroSAN, S-A-N, System of Agent Networks. And very quickly, we've ran into this requirement where if you have an agentic system and the next guy has another agentic system that is somewhat related, you want these two agentic systems to talk to each other, but they're not fully aligned. One represents one business, the other business, or maybe one represents a business and the other represents a consumer. So how do you go about that? And I'm sure we're going to talk a little bit more about that as well. In trying to see how far I can push our system and how many agents I can run on this thing, and I created an agent network of 10,000 agents. I needed a template for that, so I went with the web. So I decided, okay, I'm going to have an agent representing a page, and then the links are going to be the connections to other agents. And I was dismissing it, thinking this is not like, we have the web already, and you can always index the web. I mean, you have Google. Why would you want to represent each page with an agent? When I actually started playing around with it, it was very, very, very powerful, very useful. And also, again, anecdotally, I was talking to a client. We were talking to the marketing department of a client, and they turned to me, and their first question, I thought they'd going to ask, like, what is an AI agent, or how do you connect agents? Their first question was, how do you market to agents? So this is real. It is now, and it is standards bodies are way behind when it comes to defining it. And it stands to be, last thing I'm going to say, 40 years ago, multi-agentic systems were inspired by the web. We didn't have a Google. We didn't have a very good search engine. The idea was you have these idiot savants, these minions, that are browsing the web on your behalf. And maybe they'll run into some other idiot savant that is owned by someone else. And what is the exchange of data? What is the trust protocol? So a lot of these concepts are not new. However, today we have much, much more powerful agents, and they're much more practical.
Fascinating, fascinating. By the way, there's a lot of space on the other side if people want to just move over and join. Fascinating. So I'm glad you're talking about 40 years ago and 30 years ago for the World Wide Web. I mean, one of the earliest things that were required was to make sure that the universality principle that Tim Berners-Lee really focused on, that any website can talk to any browser. And is permissionless. Anybody can start a website without having to get permission from some platform or some piece of software or some kind of an agent store or a web store or something like that. So this universality and permissionless was very critical to keep it open and vibrant. So the question now is, and Suchao, you and I are working very closely on the notion of building a DNS equivalent for the agentic web. I just want to hear from each of you. What are some challenges you see in keeping this an open, vibrant agentic web? Because things could easily go the way they went for apps or App Store. Like we have App Store and Play Store, which started out somewhat open, but over time, because of dependencies and services, they became more and more constrained, or social media for that matter. So any thoughts on what should be done right now so that we keep it open?
Okay, I'll start first. Okay. I'm glad you mentioned about Tim Berners-Lee. I was just in Geneva a couple of weeks ago. I visited the CERN. I was fascinated first by the particle physics, the collider, accelerator. But as I see, the exhibition, I see Tim Berners-Lee's his flow diagram. When he was working there, he was the first one to propose the concept of web server. And the original purpose to serve all the participating European countries in that scientific research. It actually brings me to think, a lot of our foundational technology for internet was invented in a controlled way, managed way. TCP/IP, www, and also DNS. This started with DARPA-funded ARPANET, and for defense purpose, then they have a very specific use case. They deployed it, then they improved it, they secured it until it's ripe, it's mature, it's safe for the public. I suppose today the agentic AI or AI, it just flashed out of the gate, uncontrolled way, and it invaded the entire world. And everybody see the business opportunity, but everybody kind of forget, okay, we are actually playing on this very risky ground. There's no foundation. And I'm happy to see NANDA is a project actually committed for this purpose. It's serving the good for society, for consumers, especially for consumers. The risk is higher than for business.
Yeah, I'll actually double click on what Shichao said, right? So if you think about the internet, right, every internet endpoint or a user or an agent has an address or a name or a unique UUID. So I think what's very important in order for multiple agents to even come together, forget about whether they collaborate or they don't, we need to figure out the agent identity first. And once we double click on that, we'll figure out all the other problems that we've seen in the internet and Internet of Things, because this is not the first time we are building a complex network system in computer science. So we should learn what went well with the internet and the Internet of Things, IoT. And we should take those learnings and look at very basic computer science and operating systems, go back to our own OS courses and networking courses, and see how we can map it. Except that it's happening today, all these changes have to happen at a much faster pace. And unlike the internet, where it was just bankrolled by DARPA and a few national labs here and there, now there are a lot of players, and I would just call it a lot of geopolitical stuff at play. So you have to do it very carefully, but we have to do it very fast. So those are two, they're not too, they're not compatible goals. So it's become much harder.
Yeah, thank you, Dabo. So I'll build upon what Dabo just said. If you have read some of the key principles of agent to agent, A to A spec, one of the key principles there is the concept of agent card or agent identity, as you said. Start of this year, I had, which it doesn't happen very often, I had like 2 months to write a spec on agent interoperability. What are the key factors of agent interop? And one of the key fundamental concepts I introduced in that spec was the concept of agent card, right? Which is similar to a computer node you plug in. It has a MAC address and it can be registered in the DNS registry and distributed and all that. So in the A to A spec, we have a very similar way of defining agent uniquely with an endpoint and its capabilities. We are adding the auth signature in there. So, and then if organizations worldwide start adopting this universal standard of defining agents in a standardized way, which is based on agent card, the registration discovery, then we have a mechanism, a semantic mechanism where these agents can operate independently in a distributed environment, but then are also able to interact and understand each other. So that becomes kind of the very basic foundation of interoperability using A to A principles. Second area, I think, Dr. Ramesh, what you mentioned earlier was the how to keep it open. And I think Google did the right thing. I see Rao in the back end. Rao leads the A2A program at Google. And Google recently donated A2A to Linux Foundation. So that's one big milestone I see, that, hey, keeping the standards open and interoperable instead of just one company owning the app store and determining all the rules. So so I think that's one of the big steps. And then I think as the protocols converge and merge together, it will also become clear in terms of adoption that, hey, this is the much better standardized way of doing it, incorporating what we discussed earlier, the concepts of observability, monitoring, traceability, guardrails, and all that. I think that would all play a key role in open agentic web AI.
Yeah, I'm not going to repeat what my colleagues here said. I think I agree with all of that. I'm very happy that universities are getting involved in this. Hopefully universities can create an agentic web, basically, just like, well, I guess, I don't know if we can count on DARPA to help, but at least universities, where people would want to plug into it. And that would be a forcing function to adopt things like agent cards, which I think makes a lot of sense. And that would be the main way that we can trust agents, and agents can trust agents. And I think that's very, very important. Beyond trust is coordination. And when two agents are talking to each other that come from different agent networks, that handshake is important. And that handshake usually is one agent asking the other agent, here's what I need to do, and can you do this for me, and how do you propose doing it? And the other agent responding back. So, of course, without trust, we won't be able to do that. But at the same time, the agents should be able to do that kind of a handshake and to stake claims as to what I can do, and here's what the cost is going to be for doing that, and here's the value that you're going to get for part of the intent that you have. These protocols do exist, but they need to be standardized so that we can just plug these agents, disparate agent systems in with one another, and the agentic systems can become discoverable and break these silos. One of the issues we have, even on the web, in our organizations as well, is these silos where things become specialized and left hand doesn't talk to the right hand, and then you have these redundancies. So we stand to be able to break these silos if we can have a good, efficient coordination mechanism between these agents. And all that rides on agent cards and trustworthiness.
Wow, there's a lot there. Who came here thinking that we're going to just think about AI, and now we're talking about a world problem we had to solve, about how do we get all these minions talking minionese, as Deva was talking about. So moving on, let's talk about enterprise versus consumer adoption of agents and agentic web, especially agentic web. And if you think about kind of the ChatGPT moment, a lot of that before there was a lot of enterprise focus on AI, but the ChatGPT moment was basically a DOS-like command line interface that went viral and had 100 million users in a month and maybe a billion users soon after that. Are we going to see this pop? Like we're going to wait, and then suddenly there's something comes up and create a massive consumer adoption that drives back the enterprise adoption? Or it's going the other way. We're going to get good enterprise adoption, as Sucha was saying, make sure all the systems are working right, security, observability, transactions, and so on, and then it'll get into consumer domain. What are you seeing? I know all of you represent different enterprises. What are you seeing in that space?
All right, I'll speak first. The way it goes, I think we have to go in parallel. Consumers and enterprise. There's no sequential way you can arrange this because they're going after everything. For enterprise, I think maybe it's in a better position because enterprise has existing security parameters, enforcement point in a different form factor, and so AIs are kind of enforced in a controlled way. So you could have your tools, subsystem database are in a private, VPC, private data center, and communications are secured. You probably have much higher risk if you let your AI agent to explore talking to other agents on the internet or talking to other agents over the internet over different protocol. That's where Nanda step in to merge that protocol, make sure that we have a way to actually see everything that agents talking to agent or agent talking to tools. And that's one thing. The other thing is, on the consumer side, I think really, consumer, if you think about the way on the internet of web today, and you go browsing internet website and using TLS protocols, the web server, your browser authenticate web server, make sure they are who they are, and also the communications are encrypted. But there's no authentication on the other way. So you could have a spoofed client, spoofed browser, or bots. And for this, the problem become bigger for agentic use case. And the AI agents can be autonomous. They can reason, they can do everything on its own. So it requires a platform that actually can mutually authenticate, mutually identify, and actually can also validate the risk and trust involved before you initiate a connection. Again, this is Nanda. I'm pretty impressed with Nanda's commitment to this problem because we're protecting consumers who are really, really going to be at risk.
So I'll give a different spin to this. So being part of an enterprise ecosystem, what I see is customers actually are not completely aware that they need an internet of agents. What they are trying to solve their basic problems, as Buck mentioned, right? Like two different departments talking to each other. But even at a more basic level, they want to. Most customers have a lot of private data locked up somewhere. Every department within an enterprise, they just want to have a conversation with their data to figure out what different things with the data. And of course, they will be using an agent without realizing that they'll be using multiple agents communicating with each other to get the job done. So we see at an enterprise business level, talking to data as a big canonical use case, and then generating content as one of the big use cases, whether it's generating research or generating PowerPoint, generating sales collaterals, and all this, multi-agent systems will be kind of invisible to many enterprise users, at least for now. And so what's important is that the enterprise IT, who's actually deploying these workloads, they have to understand how this communicating agents are going to get deployed? What are the security guardrails? So they are in charge. They are on the front lines, actually. So, so I feel that the enterprise IT has to understand Nanda, and all these other new protocols. They have to understand A2A. They have to figure out agent identity. The CISO has to understand this. So this is a totally different set of discussions we need to do with the enterprise to upskill them, change their processes, and have them adopt the tech that we're talking about here today.
Yeah, great points. For us, the main customers are mostly businesses. So I'll talk more in the context of the patterns we are seeing in the B2B space and somewhat in the B2C space. But two of our top industries we are seeing with good adoptions of AI agents. Number one is financial services, and number two is healthcare, followed closely by retail and consumer goods. The patterns we are seeing in financial vertical especially is there's a lot of innovation going on in terms of how do we make the lives and more productive for financial advisors, for bankers. For example, if you're a banker, how can you service more customers in the same duration of time with assisted AI agents? For financial advisors, if I'm a financial advisor and I'm speaking to Babak for his 5-year or 10-year plan leading to retirement, I can have a retirement agent, a financial planning agent, and a market analysis agent. And before I'm meeting with my customer, these three agents can look at the data, they can look at the meeting notes, and they can prepare me an effective canvas or a dashboard like, hey, these are the key factors you should bring in, and this is how you should plan the meeting. So this is a pattern we are seeing with not just one, but multiple of our financial customers that they are starting to leverage these agents working together. And the same is case for healthcare, though healthcare being a bit slow because of all the HIPAA compliance and stuff. We're seeing there is a strong desire for multiple agents to work together, help with scheduling appointments, especially which needs more complications or stuff, right? How do we improve subscriber experience when you're just calling for an advice nurse? Can an AI agent step in and help? Our initial use cases we are seeing, it's actually pretty simple. We are seeing a pattern of 2 to 3 agents, or maybe three agents at max right now, working together. So one of the areas we are trying to see is how does it scale, right? Are 5 agents better than 3 agents? And then as you increase the number of agents, as you scale it, how do you keep the system in control? What if the agents go in a loop and you never get a response back? What does the human escalation look like? Where does the human steps in? So all these factors become really, really important when you scale the agents.
Yeah, and agentification is like peeling an onion. You start off, you create the first few agents. Next thing you know, you need to add more. Some other department within your organization has some agents, you want to connect to them, or there's some third-party agents you brought in from Salesforce maybe, or ServiceNow or somewhere else, Google, and you want to connect those in. So that just is happening naturally. One thing to note is the nature of an agent. An agent is not a model. It's not a transformation. It is a model plus code. The code is what actuates the intention of the model. Therefore, you have this choice of which part of the function of the agent goes to the model and which part is in code. So if you have a security protocol or whatever else, maybe you want to go to code. If there's some rule-based decisions and choices that need to be made, maybe that's where it belongs versus, oh, I want to understand natural language or do some reasoning and be robust where you go to the LLM. I think that acknowledgement is really, really important. Before you know it, these agentic systems need to go out to third-party agents that are owned by others, and we talked about that briefly as well. Our recipe is the CIO department owns the nucleus of the agentic system and sets it, and then empowers everyone else in the enterprise to build their own agentic systems, and then through a series of steps to validate and test and safeguards and so forth, allows them to then be plugged into the larger agentic system. And I think that model within an enterprise might actually also be something that we can do outside of an enterprise and on the worldwide agentic web.
Wow. Sounds like agents, agentic web, peeling an onion, going to be a lot of tears along the way.
That's a good
and,
point.
And as Davos said, I mean, the agents might be minions. They might be talking minionese, but at some point we will become the minions, and we'll have to learn the minionese. Thank you, everyone.
Thank you.